Hi everybody, this is Perfect Competition video number 2. We have 3 objectives here. We're going to think about efficiency, allocative and productive efficiency, and we're going to apply those 2 lenses to conditions where the firm is making a profit or taking a loss or breaking even. And then we're going to think about the shutdown rule, which is where the firm has to face the unfortunate situation of a very, very low price, and think about reasons why they should in that instance violate the MC equals MR principle of how much quantity you should produce to maximize profit. And then the last thing we'll do is think about Mr. Darp's mood ring and the different ways that we can analyze that marginal cost curve one more time to derive the firm's supply curve. So that's our big objectives for this one. Let's review a little bit about the 2 kinds of efficiency. We have allocative efficiency and productive efficiency. And allocative efficiency was making the right mix of things, and in particular making the right quantity of each product. And that meant that the marginal benefit that a consumer would get from having the very last unit produced would equal the marginal cost of making that unit. So however many resources it took to make that very last one, somebody would enjoy it exactly that much. There'd be no deadweight loss. And so we'll think about when a perfectly competitive firm is allocatively efficient, and we'll be checking to see if the price they charge their customers equals the marginal cost of the Q-STARF unit. Ooh, that's fun to say. What do we have next here? Productive efficiency. That means making each one as cheaply as we can. So we're looking at ways that are we making the quantity that will minimize ATC. So there's all sorts of quantities, and only one of them will lead to the minimum value of ATC. Otherwise, we're making each one a little more expensively than we have to. So when is a firm perfectly competitive firm productively efficient? Once you keep those 2 questions in mind, we'll put them to the test over the next few slides. So here we go. Here we have a situation where the firm's in long-run equilibrium. And we can see here that this is market supply and demand. This establishes a price. The firm is a price taker, and so they face this perfectly elastic Mr. Darp horizontal demand equals marginal revenue curve right here. And they respond to that by saying, what quantity should we produce? And they produce the quantity right here where MC equals MR. Now, if they had produced that quantity there, then they would have experienced an ATC up here. If they had produced that quantity here, they would have experienced an ATC up there, but marginal cost would have been way higher than marginal revenue, so that would have been telling them, no, you made too many. So they went ahead and made this quantity. And what was their average total cost? Their average total cost was, in fact, this exact height right here. It was its minimum value. So we can say, yes, they are being productively efficient. What about allocative efficiency? We want to know whether price consumers pay equals the marginal cost of the last unit produced. Well, it does, right there. The marginal cost of any unit, see, if we'd made this many, the marginal cost would have been here. If we made this many, the marginal cost would have been there. But we made this many, and so that's the marginal cost of that last unit, which is the same as price. So we are both kinds of efficient when we're in long-run equilibrium. Okay, so there's some sad news here. We're not both kinds of efficient when we're in this situation. Economic profit for the firm is great, and the firm has this profit box here. But let's focus now on that bottom right corner of the profit box. That's where the green dot is. And that green dot is the ATC that the firm experiences. They make Q star units because MC equals MR up here. They're following the rules correctly. And so this is the ATC they experience. And note that that green dot is higher than the red one. And here's a bit of strategic advice, especially if you're showing a profit situation, but it's true for a loss as well. You want to make sure that your ATC has a defined minimum point and that it's coming up clearly on both sides from it. And when you draw a profit, notice I drew a nice big high profit, because if the profit's kind of small, then your dot looks often like it's directly next to the red one, and you want it to really be above that. You can even make the dot further out here if you want, but that requires having a very tall graph. Or another strategy you can use is take marginal cost and don't make it as steep of a swoosh. If you make it a little bit more of a gradually sloped swoosh, then you'll be able to swing out a little better on ATC to form that spot there. not productively efficient. Are they allocatively efficient? Well, here's the price they charge right here. And what is the marginal cost of making that Q starth unit? Well, yeah, it's the same. So they are allocatively efficient, but not productively efficient. How about a firm taking a loss? Well, we can check their loss box. We've done this before. You can see it's right there. They saw where Mr. Darp was, and they decided, here we're going to go to where Mr. Darp crosses marginal cost, and they're right there, taking a loss. They've decided to produce that quantity because that's the quantity where their profit, though negative, is still at its greatest value. Are they productively efficient? Well, here's minimum ATC, and their ATC is actually the top of this dotted line. Notice in order to make our loss box, we had to extend the dotted line above Q, little lowercase q star, up to ATC, and that was the corner of our loss box. ATC of Q star will always be the upper right corner of a loss box and the lower right corner of a profit box. So being able to find ATC of Q star and distinguish it right there, to distinguish that from minimum ATC. And note that the purple dot is not just to the right, but below the gray one. That's a key skill to have. And you want to practice drawing ATC several times to make sure that it's steep enough so that you can reflect this when you do your graphing. And this is also imperative to read the entirety of a free response question before you start committing to a graph, because later in the question, if you have to shift a curve, you want to make sure you strategically plan to leave yourself space to shift that curve neatly so that there's enough space to squeeze arrows in between and all of that. All right. So is this firm allocatively efficient? Yes, they are also, because the price equals the marginal cost of production. So in general, though, they will always be allocatively efficient because they'll want to produce where MR equals MC. If they're maximizing their profit, they are allocatively efficient. They produce where MR equals MC, and MR equals price all the time because of this horizontal line. They won't be productively efficient unless they're in long-run equilibrium, though. All right, let's move on to the second part of this video, and now let's think about that shutdown rule, or what shows up on your vocab sheet as shutdown conditions. Here we face a really traumatic situation for the firm, right? Look at the market or industry graph, and you can see that supply and demand intersect really low, which means that the price is low. So they, as a price taker, have to accept this low price down here, and they surely wouldn't choose that, but that's the way it is. And now the question rises, should they produce or not? And because the slide's titled The Shutdown Rule, of course, you know that they shouldn't, but let's lead us through why. And the best way to understand why is to think, well, what would they produce if they did? And let's compare it to what if they hung up a closed sign and said we're not producing any. Now, just one clear definitional thing, saying we're going to shut down is different than saying we're going to exit the industry. Shutting down is something we can do in the short run when we hang up a closed sign and say we're not producing any quantity. We're going to incur no variable cost and take no total revenue, and we're just going to have costs equal to our fixed cost. So our loss would equal our fixed cost. So that's an important thing to think about, because we want to think about the idea that the worst a firm should ever do is to lose its fixed cost. Anything they would do involving producing should only decrease their loss from the maximum possible, which would be the fixed cost if they produced a quantity of 0. Now, we'll also keep in mind that fixed cost is the same no matter what quantity you produce. So if we can find a box, and you can see it down here, that represents fixed cost, it really doesn't matter how tall or wide that box is, it would always be the same area. If we think about that stick of butter, I even made it yellow, so it's like a stick of butter. So let's think about some areas for the firm if they should choose to decide to say, I'm going to produce where MC equals MR, because if they're going to produce, that would surely be the best quantity to produce. Here, we'll follow our same procedure we did in video 1. We'll think about the total revenue box, and there it is. It's really small. It's really short. And they produce a small quantity if they choose to, and there's P times Q or Q times AR, and there you get your total revenue box. Very low price. Okay. They have some costs too. And here are their costs, right? Look at that. Okay. How did I come up with their cost box? I took ATC of Q star, that's the height, and Q star. So it's quantity times average total cost. And that gave me total cost. Now, for sure, I can think about total revenue and total cost, and then the big gap that's glaring at me, and I even made this box too small, but there's economic losses. Wow, they're big, big red box. Okay, we're in the red. All right, I'm going to move those out of the way, and now I'm going to take advantage of a different knowledge that I have. Of course, total cost is total revenue plus economic loss. We can see that graphically, and we know that algebraically too. But another way total cost can be thought of is that it's FC plus VC. So how would we think about that graphically? Well, here's the variable cost the firm faces right here. That is average variable cost of making Q question mark times Q question mark. Well, the rest of their cost is fixed cost. And we know that that's average fixed cost. Note my formula is ATC minus AVC. It's average total cost minus average variable cost. That's just another name for average fixed cost times the quantity. Well, that would be our fixed cost no matter what. So there we are. Now, we have a box that represents fixed cost and a box that represents economic losses. And we can totally see that one of them, they're the same width, and the red one is taller. So would you rather produce and incur costs and end up losing the red box, or produce a quantity of 0, hang up a close sign, and lose only the yellow box? And the rational thing to do would be to lose only the yellow box. So that's the reason why the firm should produce a quantity of 0 units if the price was this low. Let's go ahead and generalize and put that into words. But before I do, I would encourage you to think about doing the same process on your own graph with a Mr. Darp that's in here to prove why the firm should produce even though they're going to take a loss. Because that's a little bit of a counterintuitive result for many students, is they think that they should only produce when it's up here when they're making a profit, not when it's in here where they're taking a loss. And why would they produce here where they're taking a loss, but not produce here where they're taking a loss? And these areas are the key to figuring that out. So try this process again to prove the opposite result is true when Mr. Darp comes in between. What's the summary of the shutdown rule? Here it is. If Mr. Darp lies beneath AVC and never crosses it, then the firm will choose to produce 0 units or shut down rather than the quantity at which MC equals MR. This is true because shutting down, producing 0 units in the short run, and not the same thing as leaving the industry in the long run, leaves them with a smaller economic loss than producing will. There is no quantity the firm could produce that would lead to a smaller loss box than their fixed cost. When one of these is true, all are true, and the firm should shut down. I encourage you to think about why one of these necessitates all of them algebraically. Price less than average variable cost, total revenue less than variable cost, loss greater than fixed cost, and per unit loss greater than average fixed cost. So that's a little bit about the shutdown rule. And now we can think about the last part of the video, which was the mood ring of Mr. Darp. So for those that don't know, mood rings are these funky things you can wear, and they change color based on whatever your emotions are. Well, here we have Mr. Darp and some of his mood rings. And if you remember anything about a mood ring, then you might know that the blues and the greens are when you're happier, and the reds are when you're not as happy. And I'm going to bring my supply and demand curves over here so that I can think about a lot of price changes. And I want to think about big price changes. Mostly what we're going to think about is on this left graph of the firm. But in order to do big price changes with small quantity changes, I'm going to take advantage of what I learned about elasticity in the first unit. And I'm going to grab demand and supply and make them just a little bit more inelastic, so that I can see bigger price changes over a small range of quantities. So there we go. Let's imagine first the greatest possible situation for the producers in this perfectly competitive industry, which is that the firms are earning a profit. The price is up here at P5, and so they face this green Mr. Darp up here, and they're earning a profit. You can sort of visualize their profit box. They're going to produce this quantity right here, I think, when MC equals MR. Not that one, but how about this quantity right here is what they'll produce. And they're gonna situate their production right here. So that is a point on their supply curve. Like if you tell me this is the price, I'll tell you they'll make this many. It's a relationship between price and quantity supplied, which was what we established as our definition of supply long, long ago. And so then let's imagine a case that's slightly less optimistic for them. But let's imagine that the price is now here at P4, so we're going to focus our eyes on the blue. I know there's a lot of lines on this graph, but just think about the blue right now and the black stuff in the background. So here we know this is a situation where the firms are each breaking even. Each firm has well, I guess we have a gray dot. That's kind of interesting. We'll use the gray dot. But they're operating right there. They come and look at this situation about the world and they say, hey, if the price is price blue, then I'm going to go to where MC equals MR, and that's going to be right here. That's the quantity I'm going to make. So that gray dot would be another point on their supply curve. And if you repeated this for anywhere in between here, you'd find that the same set of points that's their marginal cost curve is also their supply curve. In between, we have a representative sample of the we'll take a loss but we'll still produce level of price. So let's imagine demand descending again to price P3. Now we have this price established in the market, and I'm a price taker. So I look at that and I respond and I say, how can I make marginal cost equal marginal revenue? And so here I'm looking at the purple and the marginal cost is below. Marginal cost is still below. Marginal cost is still below. Okay, keep producing. Well, now marginal cost is greater up here than marginal benefit or marginal revenue. So what I know is I need to go back and produce right there. There we are. Okay, that must be a point on my supply curve as well. And what about this situation is kind of a special one we haven't talked about yet, which is one where Mr. Darp ends up at price P2, and it's just tangent to the bottom of AVC. And I suppose at that red dot, you could make the argument that the firm is indifferent between producing and not producing, because their loss is exactly the same as their fixed cost. Now, I think generally an econ will assume that they produce, because if you started a business and worked hard to make that business succeed, you would really not want to hang up a close sign and say, sorry, we can't play. But there it is. So anyway, that's a situation. And then we could kind of examine one more here. Boom. What if price was at P1? Oops, I forgot to put that in. What if price was at P1? Well, would they produce down here? Hopefully you watched the early part of this video where you said no way they would produce a quantity of 0. What is the fundamental lesson here? The short-run supply curve for a perfectly competitive firm is the portion of its marginal cost curve that lies above minimum average variable cost. If we wanted to identify, there's that definition again. That's one that's worth memorizing. I used to force every student to memorize it, and then they asked questions that were exactly that phrasing on the AP test for a couple of years. It was kind of cool. They made me a shirt. At any point, if we come back up here and we say, let's look for the set of points that is the quantity the firm would supply at any given price, it would be these points right in here, all of these ones. So if you want to be really snazzy about your perfect competition graphs, you'll do multiple or marginal cost and supply and have some cool way of shading or adding a color or something where you can be like, here's the part of marginal cost that is supply. Or sometimes I've seen students, they'll do this part in dotted line and then they'll make it solid above that, which is pretty cool too. But at any rate, hopefully now it makes sense why I've had this other label hanging over here, which is that the supply curve for the industry is just the horizontal summation of all the firm's marginal cost curves. And that hopefully stands to reason, because if this is how many I'll make at this price, and you take it multiplied by 1,000 or however many other firms there are in the industry, that'll be how many we all will make at that price. And so that really would be the horizontal summation of everybody's marginal cost curve. And each firm's marginal cost curve would be just that portion above AVC would be their supply curve. All right, hope we're doing well, and we'll have one more of these about changes in the long run to come.